Dear students, so we are going to start with our new video. In this video, we are going to see the next metal joining process, that is brazing and soldering. So this is metal joining process, brazing and soldering. It is a part of unit number 5, that is introduction to manufacturing. So we'll see these two processes, brazing and soldering. So first we'll see what is meant by metal joining process, that is brazing. So if you see in brazing process, we have brazing is a metal joining process which is done by the use of heat and filler metal. So we have both heat as well as filler metal. So we have, this is the filler metal and this is the torch by which we perform the heating of that filler material. So brazing is a metal joining process which is done by the use of heat and filler metal whose melting temperature is above 450 degrees Celsius. So in brazing process, the melting temperature is above 450 degrees Celsius, but below the melting point of the metal. Okay, so we heat the metal above 450 degrees Celsius, but below the melting point of the metals. So this is the definition of the brazing. So brazing is, we can say there is a difference between brazing and welding. So first difference is in case of the composition of filler metal, or we can say alloy, that is called as brazing metal, is different from base metal. Okay, so in this, the base metal is having a different metal and the brazing material is having a different metal. Okay, generally the copper and its alloy is used as a brazing materials. Next one is the strength. If you see, the strength of that brazing joint is less than that of the base metal. So if you see, the strength of brazing alloy is lower than the base metal. So the melting point of this brazing material or brazing alloy is lower than your base metal. So in brazing, we heat the filler material above the 450 degrees Celsius, but below the melting point of the base metal. The melting point of brazing alloy is lower than that of the base metal. So the base metal is not melted. In welding process, this metal is melting, but in brazing method, there is not a melting of this base metal. So there is a melting of brazing alloy only, or we can say filler metal. Next, generally in brazing, the bonding requires a capillary action in the brazing. Okay, so this capillary action is required to bond we can say joint between two base metal or two pieces of the base metal. So brazing requires a clean surface. Then there should be a proper clearance between metals, good wetting of the joint, and good fluidity for the brazing alloy in the joint. So the brazing alloy, or you can say a brazing material, it should be flow within this joint. So these are the requirement that is required in the process of brazing. There are different types of brazing metals that are used. So the most commonly used brazing metals are copper and copper alloys. Okay, so this is most commonly used. Second one is we have silver and its alloys. So silver and silver alloys, aluminum and its aluminum alloys. So these are the brazing metals whose melting temperature is above 450 degrees Celsius, but below the base metal other than these alloys, copper, copper and alloys, silver and silver alloys, and aluminum alloys. Now we will see, if you see the brazing process So there are different types of brazing methods that is used to join these two base metals or metals piece by using brazing methods. So first, generally, these methods are, so, or we can say brazing methods, or we can say it is the steps which is involved in brazing. So first step is we have to clean the joint. Okay. So we have to clean this joint where the brazing is to be done. So we have to clean this surface or joint. Next, we have to set the proper clearance between these two joints or two metal pieces. Okay. So this is the first step, that is cleaning of the joint and setting the proper clearance between the pieces of metal plate. Next one is then the next is we have to apply flux to the joint. Okay. So this is the second step. Third step is heating of the joint. So we have to heat this joint to bring it into a liquidous temperature of the brazing alloy. So we have to heat the filler material, that is a brazing rod, so that it will comes to in a liquid state or melting state, so that it will flow along the length of the joint. So this is the third step, that is heating. Fourth step is apply brazing material so that it flows into the joint by means of capillary action. So along the length, it will flow between these two metal plate or faces. Next one is the brazing metal may also be pre-placed in the joint. Sometimes we can put the brazing metal before we applying heating, or we can say before we flow, this heating process will be start. So that can be placed between these two joints, or we can say two faces of the metal plate, or in this there is a metal plate or there is a metal pieces. Next one is the brazing metals on solidification. It gives, so when we allow this, we can say the solidify to this joint, so it will give the necessary joint strength after the solidification. So if you see, there are different types of, this is the torch by which we apply heat. This is the filler material. So by heating this filler material, and we have a flux will be there, so that will protect this filler material from the oxidation. So if you see, when we do the heating by means of capillary action, the melting is done and the metal will flow along this joint, and this whole joint, it is joined by means of a brazing. So based on method adopted of for heating, they are classified into various types of brazings. So first, it is the torch brazing. Now, if you see in this figure, we use a torch for heating the filler material or brazing material. Second method is deep brazing. Third method, it is called as salt brazing. Then we have fourth method, that is furnace brazing. Fifth, induction brazing, and sixth, resistance brazing. So depending upon which method is adapted or which method is used for heating the brazing material or filler material, the brazing, it can be classified into different types, that is torch brazing, deep brazing, salt brazing, furnace brazing, induction brazing, and resistance brazing. So we will see these different types of brazing methods one by one. So first method is torch brazing. So we have seen this torch brazing. So in this torch brazing, the source of heat for brazing is gas flame torch. Okay, so by this torch, the gas flame is there, and by means of this gas flame, we heat this brazing rod or filler material. So this gas flame torch, it may be of oxyhydrogen flame or other gas flames. Okay, so this type of first method which is adopted for heating of the brazing material or filler material, it is torch brazing. So if you see the example of torch brazing, and the second type, it is called as deep brazing. So this is the diagram for deep brazing. So if you see in deep brazing, the pre-assembled metal joints. Okay, so pre-assembled metal joints is there. So we have assembled these two metal joint or brace piece is there, and we have this brazing workpiece. So we have pre-assembled work joint is there. They are dipped into a bath of molten brazing metals. So there is a molten brazing material is there, and inside this we put the brazing workpiece inside this molten brazing material with molten flux will be there, and after that it will take a joint. So molten brazing metal bath provides both required heat and the brazing metal for the joint. So it will heat as well as because of that it will provides the joint between these two metal pieces. So it is usually adapted in a small part. So where there is a small joint is there, small brazing joint is required. So in this process, we apply deep brazing. Okay, so we required a small part, but we have huge number of, we can say, component will be there. Next, this is again diagram for this deep brazing. So we have next is the salt brazing. So in case of salt brazing, the assembled part is dipped into bath of molten salt. Here there is a bath of molten brazing material or filler material. Here there is a assembly part of bath are dipped in the bath of molten salt, which is kept slightly above the melting point of the brazing material. So because of this, the brazing metals are pre-placed in the joint, and the molten salt bath provide heat to melt that joint. Okay, so already there is filler material or brazing material is there, is provided between this joint, and then it is dipped in the bath of the molten salt, and because the temperature is higher than the temperature of filler material, so the brazing material it's melting and it will flow along the joint. Okay, so this is the salt brazing. So we have seen these three methods of brazing, that is torch brazing, deep brazing, and salt brazing. Now we have next brazing, that is fourth. It is called as a furnace brazing. So if you see in furnace brazing, the assembled metal joints with pre-pressed brazing metal are kept in controlled atmosphere or vacuum furnace. So pre-assembly of the metal joints, they are placed into controlled atmosphere or vacuum furnace. And because of the easy control of brazing temperature, we does not require any skilled labor in this furnace brazing. So furnace brazing, it is used for a mass production. That is, there are continuous production will be there and large number of component is to be brazed. So that is used in furnace brazing. So next, so if you see, this is the actual image for furnace brazing. So we have a furnace, and these are the components. They are passes through the conveyor through this furnace, and after that we get the brazed joint, that is joint between the two metal pieces. So this is the furnace brazing. Next types of brazing based on heating, it is the induction brazing. So if you see, in case of induction brazing, the high frequency induction current, it is used for heating the joints. And the induction brazing requires a simple heating coil. So we have a heating coil is there. That coil is called as induction coil. So we have a material 1, material 2 is there, and between there is a pillar material. So in induction brazing, we require simple heating coil which should fit around the joint, which provides the heating around this joint area. And the brazing meter is again pre-placed between these two metal joint, and after heating, the brazing material gets melted, and it will we can say, due to capillary action, it will form a joint between two material. So this is an example of the actual image of induction brazing. So we have a heating coil or induction coil, and because of that, the heating is done, and the two metals it get joint because of this heating of the brazing material, and this brazing material is pre-placed inside the joint between two material, material 1 and material. And the last brazing method, it is called as the resistance brazing. So this is the diagram for resistance brazing. In resistance brazing, the metals to be joined, they are held together under the pressure. So we apply the force or pressure between two metal pieces where we require a brazing joint between two electrodes, and the heating is due to the electric resistance between these two electrodes. So we supply the electric current, and because of that, the heating is done between these two electrodes, and we apply the force to this electrode so that it will get heated. So from that we get the brazing. That brazing method is called as resistance brazing. Now we will see some advantages, disadvantages, and application of this brazing. So first we will see advantages. So in brazing, the filler metal in brazing operation has low melting point than the base metal. So we require less heat. Second, the operation for joining different metals, non-metals, that can be possible. So by using this brazing method, we can join metals as well as non-metals, both. In welding, we require metals only. But in case of brazing, we can done this joining process in metal as well as non-metal. Next, in brazing, we does not require any final finishing operations after completing joining process. So cleaning of this joint does not require. It is required in welding process. Next, in this operation, as base metal does not melt, so we can remove the joint when we require this brazing joint. So we can, it is the removable joint, as the operation does not done on the metal. Next, this brazing method, it is useful for large production. Brazing, there is a control over the thermal distortion by maintaining uniform heating, and the heating is also very low. So because of that, the thermal distortion, or we can say thermal properties, does not change of the base metal. Again, the properties of base metal do not changes. So these are the advantages. Now we have disadvantages. So first disadvantage is this method of joining has less strength than the welding. Second one is this method of joining metal cannot work under high temperature. So we require very low temperature. And third, this is not useful for a long joint is there or long welding is there. Okay. So it is used for a small parts. Applications. So the brazing is used in heating ventilation system where we use different pipes, small pipes. Then it is used in aerospace, constructions, and electronics. So there are different examples of this brazing from air conditioning systems to jet turbine base to fine jewelry. So we use this brazing method. Now we have seen the first metal joining process, that is welding. Now in this video we have seen the metal joining process, that is brazing. Now we will see the next method, that is the soldering method. So again, a soldering is a metal joining process in which there is again joining of the metal done by use of heat and filler metal as like brazing, but the melting temperature is below 450 degrees Celsius. So there is small difference between soldering and brazing. It is that in soldering, the melting temperature is below 450 degrees Celsius, while in brazing, the melting temperature is above 450 degrees Celsius. All other definition, it is same as that of the brazing. So next one is the joint strength is relatively low in case of soldering than both we can say brazing as well as welding. And the joining is due to the adhesion between the filler material, that is called as a solder mainly, and second one is the parent material or base material. Next, so if you see, we have a solder wire that is used as a filler material, and there is a soldering gun, or we can say soldering iron is there, and we supply heat at this tip of the soldering gun, and because of that this solder wire gets melted, and the joint will be provided between this, that is the solder joints. So there are different types of solder metals mainly used. The most solder metals it is used is alloy of lead and tin with little amount of antimony. However, tin antimony alloy are mostly used in electrical applications. Then we have other solder materials like tin zinc, then cadmium zinc, aluminum zinc, then cadmium silver alloy. They are used for if there is high temperature service is required or high temperature is required. But for most of time we use this alloy of lead and tin as a solder metals. So the basic steps of soldering is again same as that of the brazing. So the joint fitting, so there is we required a clearance, that is this much clearance it is in required. So a clearance of 0.005 inch, it is suitable for most of soldering. When soldering pre-coated metals are there, then we require a clearance which is 0.001 inch. Next, there are different types of cleaning. So first we have a joint fitting, clearance is there. Next, we require a cleaning. Now there are two types of cleaning will be there. One is mechanical cleaning and another one is chemical cleaning. So the cleaning of these surfaces which is to be joined, it is cleaned by either a scotch brite pad or by using emery cloth. It is a mechanical one. Or if you use the chemical methods for cleaning, so we require the acid to remove the rust, scales, or we can say sulfides. And most commonly, we use the hydrochloric and sulfuric acid for the cleaning of the joint we can say the cleaning of the base metal or parent metal. Next, after that, we have to apply the flux. So this is the next step. So flux should be capable of removing the oxides and stop them from the reforming. Next, flux should permit the displacement of solder also, and the flux should promote the wetting of the surface by the solder. So this is the third steps, that is application of flux. Fourth step is application of heat. After applying flux, we have to apply the heat. So heating the joint evenly or uniformly is utmost important to ensure good joint or sound joint. Now there are different types of soldering equipment is there that is used for applying heat. That is soldering iron, where we use the electric supply. Second one is the plumber's torch, that is propane low heat there. Then in case of deep soldering, we have a large tank with molten solder to solder multiple joints at a time. And we have again, as like furnace brazing, we have oven heating. So it is only used in a production where other heating methods are impractical. So in that we use this oven heating or furnace heating. After that, we apply solder. That takes place it into a two steps. The first step is wetting the metal surface, and second one is we have to fill the gap between wetted surface with the help of filler material, that is the solder. And the last one is the cooling of the joint. So as soon as possible, solder joint may be cooled using either water spray or using air blast. So there is, as soon as the solder point, it may be cool. And if there is slow cooling, that causes the excessive alloying, and that results into a brittle joint. So the joint is not a good joint. That is the brittle joint. It will weaken, or we can say it will break fast because of slow cooling. And last one is we have to remove the flux. So that is called as flux residue treatment. So non-corrosive flux are ones which are rosin base and do not require removal. If we use this non-corrosive flux, so we does not require to remove this flux. But if we use the corrosive flux like zinc chloride, so in this we have to remove this flux so that it will prevent from the corrosion. So these are the different steps which is used for the soldering. It is same as that of brazing. Also we use same steps. So if you see how the soldering technique for the kit building is there. So we have to assemble the proper tools. So we have goggles, safety goggles, and for cutting. Then this is the filler material. Then this is the solder gun, and this is the PCB circuit where we use the circuit. We can say we use. We can say we have to remove this different equipment are there. Now next one is we have to place the filler material or solder like this, so that if we melt this solder or filler material, solder wire, it will take we can say joint as like this. So assemble the proper spool. Second one is we have to mount the component by bending the leads out slightly. Third one is we have to heat the iron, or we can say iron gun. Then we have to clean the tip by using this either you use a mechanical or chemical process with damp sponge. After that, we apply the heat on this lead. and after that we remove the solder, and after that we cut out this filler wire, or we can say solder wire extra, and we get this a soldering joint. So we cut out this lead and we get this solder. So these are the basic soldering technique which is used. Now next we have the advantages of soldering. So first advantage is this can be operated on low temperature. Again, in this we does not require to melt the base metal. Next one is any metals and non-metals, they can be joined by these methods. Again, this required a very low power supply because solder gun we require very less amount of heat is there, so we require very low power. Again, very less time is required to join this by using the soldering, and this can be easily operated, does not require any skill labor and all that. Next, we have a disadvantages. So first one is strength is less. Second one is this is not useful when joint works under very high temperature. Next one is it is not useful for long length welding. So it is required for very small joint is there. Next, heavy metals, it cannot be joined or welded by this operation. And there is a chance of toxic component at fluxes. Now, because of this flux, the toxic component that can be flow. Then applications, the soldering, it is used in assembling mainly electronics parts or electronics components, which is on PCB, that is printed circuit boards. Also making permanent, or we can say permanent but reversible connections between copper pipes in case of plumbing system. So these are the applications of the solder. Now, this soldering joint, it can be also used in sheet metal objects such as food cans, roof flashing, then drain gutters, automobile radiators, then jewelry, semi-permanent patch for the leak in container or cooking vessels. So these are the soldering applications. Now we'll see the what are the differences, or we can say distinguishes points between brazing, soldering, and welding. So we'll see these different points. So first, brazing, soldering, and welding. So first point is the brazing joints are stronger than soldering, but it is weaker than welding. So brazing can be used to bear some load or some force. In case of soldering, it produces the weakest joint. So soldering produces the weakest joints between these three, that is brazing, soldering, and welding. So soldering joint is the weakest joint, and it is typically used in electrical contact. So it cannot bear the much weight or much force. So welding joint is the strongest joint amongst all this brazing, soldering, and welding. And the strength of welding joints is often exceeds the strength of base metal also. So strength of weld joint is more than the strength of the base metal. Now, if you see brazing, the temperature is as much as 1000 degree Fahrenheit. In soldering, it is around 800 degree Fahrenheit. And in welding, it is above the up to the 7000 degree Fahrenheit. So the lowest temperature is in soldering, then the moderate temperature we require in brazing, and higher temperature we require in welding. So in case of brazing, the workpiece is heated below its melting point. In soldering, we does not require heating of workpiece. So only we heat the solder or solder wire or solder metal. In case of welding, the workpiece is also heated up to the melting point. Here below melting point, here up to the melting. Next, in case of brazing, the mechanical properties of the joint may show the negligible change. Here, in case of soldering, there is no change in mechanical properties. In building, the mechanical properties of base metal may change because there is a heating and cooling is there. So heating is above or up to the 7,000 degree Fahrenheit, and there is cooling also. So because of that, the properties of base metal or workpiece may change. Next one is in brazing, there is a cost involved and we require skilled labor than this soldering and brazing. Now, in case of soldering, there is a cost involved, but skill requirement is very low. Here, welding, we have very high cost as well as very higher level of skill is required for the welding. Now, in case of brazing, no heat treatment is there required. Again, soldering, we does not require any heat treatment. But in case of welding, we require heat treatment to eliminate unwanted, we can say, effects of the welding. Next one is in brazing. Because brazing is done at lower temperature, so preheating can help to form the solid joint. In case of soldering, we can use the preheating of workpiece before soldering is done, and it is also good for the making the quality joint. Since the welding is performed very high temperature, so the preheating is not necessary in case of welding. So these are some distinguished points between three metal joining processes, that is brazing, soldering, and welding. So this is all about the today's, we can say, in this video, we have seen the metal joining processes, that is brazing as well as soldering, and we have seen the comparison between all these metal joining processes, that is brazing, soldering, and welding. So thank you for watching my video. Also, please subscribe to my channel and like the video. So thank you very much.